Sup bitches? I'm reliably informed that I'm terrible at pimping my stuff. So here I am, pimping my stuff in what's hopefully an amusing way. If you want to interact with me and follow me, you can find me on Twitter at Grinosaur and at Mort_post for official announcements. Hello lovelies, hope you're all keeping well. We're going to talk today about COVID-19 or the coronavirus, which means I'm instantly demonetized, which is good because that means I can fucking swear as much as I fucking want and it'll make no fucking difference. We're going to talk about it in the context of games, or disease more generally in the context of games. When you're a long-time gamer, particularly a tabletop gamer, and especially when you're a game designer, you take inspiration from the world around you. You watch a film and you think of it in game terms. You watch the news, you think of it in game terms. My Cyberpunk campaign that I'm running at the moment for my regular group is 2020 in 2020. So we're taking inspiration from the news, giving it a futuristic spin by essentially moving the technology and politics into the even darker timeline a little bit advanced. But it just means that every month and a half or so before the game, I can look at the news and I can create plots out of stuff that's going on in the real world, which instantly grounds it and makes it seem a lot more realistic, plausible, and it means that I can take tech news and speculate from that into potential future technology. It's quite an interesting and good way of doing things, and if you're short on inspiration for any game, fantasy, futuristic or whatever, looking at the news can be a real boon. So if we look at the coronavirus, these are the statistics as I understand them. Feel free to correct me if you're more of an expert or more up to date than I am, but I did just check these this morning. The reckoning is that about 60% of people worldwide will be infected. Of those, about 80% of people will have a mild reaction or be completely asymptomatic, though they may carry it. 15% of people who are infected will have a severe case, which probably won't require hospitalization but will require particular care. About 5% of people will have a critical case, so you can see that's already taken us up to about 100%. And those critical cases will require hospitalization and may result in mortality. And the mortality rate, which is extremely difficult to judge because lots of people are asymptomatic, is somewhere between 0.6 and 4%, which is a huge gap. By way of comparison, the Black Death killed about 1/3 of people. So you've got that as a point of comparison. It makes it seem not so bad necessarily, but we should definitely take it very, very seriously. Wash your hands, telecommute, take it seriously, and isolate yourself beyond the essentials. Please, that will contain it. Real life will get in the way. Well, this is real life, but yeah, if you can do those things, wash your hands, telecommute, take it seriously, and isolate yourself. So let's talk about diseases in a game context then, because I think we're living in a time that's allowing people to see the further reach and the further implications of disease, when most of the time we've only really ever thought about it in a kind of post-apocalyptic scenario, I suppose, or a zombie uprising. But just a regular old disease can be pretty terrifying and pretty effective. There are 4 main types of communicable disease. There are viruses. These are the smallest. They can get through typical protections that people might wear, such as breath masks and so on. Very small. And what they do is they get into a cell and they suborn that cell and use it to produce more versions of themselves. So they parasitize a cell and essentially convert it into more copies of the virus. Viruses are relatively simple. Whether they're life or not is it's a subject of debate. Prions, which are a type of protein, they're not really alive. I think the general consensus is there, but with viruses, it's questionable. They're capable of evolving and mutating and so on, but are they alive, or is it something that's purely mechanistic? Anyway, the way they work is they infect your cells and turn them into more copies of the virus. That's one. Bacteria are single-celled organisms, so they are another life form. And they get into your body and they use your resources and they reproduce rapidly within you. And typically the symptoms and so on that you get from those is a result of byproducts of the bacteria's own metabolism and so on. So they may produce toxins like the botulism toxin, things like that. But that's a single-celled organism that's capable of rapidly reproducing. There are parasites. Parasites are as small as a single-celled organism, like a paramecium, or they can be multicellular organisms, such as types of flatworm or nematode, or intestinal worms, or all manner of other nasty, horrible things that squick us out when we really think about them. They can be inside your body. Flukes can burrow into your liver and insist themselves there and reproduce. Others can infest the exterior of your body, like lice, for example. And it may be that there's a complex life cycle with a parasite. So it may have an adult form that may lay eggs. Those eggs may be eaten by an animal, at which point they go through their first change. We may then eat that animal, at which point they go through the second change. And then we pass their eggs in our shit, or whatever else it might be. Parasites are really interesting because they can have far-ranging effects on our behavior, and they can kind of twist our bodies to their own ends. The interactions between a host and parasite can be quite profound. This is also true to an extent with fungal infestations. Fungi are another type of single or multi-cell organism that can infest us. Yeast infection is a type of fungal infection. Cordyceps, which we're all aware of from The Last of Us, is a kind of fungal infection that can modify the behavior of the host, as we were just talking about. Athlete's foot, you can get toenail infections, which are fungal. They're often difficult to treat, but we also often end up in kind of harmony with fungal infections, and it's only when our immune system is suppressed or other problems, other health problems are taking up our body's resources, that fungal infections can really get out of hand. So where do diseases come from? There's not that many ways that diseases can come about, but there's some new ones on the horizon which are perhaps concerning. So we'll consider some of the kind of speculative sources of disease here as well. The primary source is mutation. A mutation in an existing disease, which becomes more likely the more widespread the disease is, because there's more opportunities for it to mutate. But a mutation can change a disease that already exists in a way that makes it a lot more dangerous. It may just be that it finds a way around our existing bodily immunities to a disease, like a mutation of measles perhaps, might get around current vaccinations. It may be a change in how infectious it is, or how easy it is to pass from one person to another. Like if Ebola went airborne, for example, that would be a huge problem for humanity as a whole. So mutations of existing microorganisms and diseases, even ones that are currently benign, into something that's bad, that's one way that novel diseases can arise. Zoological sources is another potential source, and this is why the wet market was initially blamed and bat soup was initially blamed. AIDS is thought to have transmitted its way to humans through bushmeat in Africa, or even possibly someone having bestial liaisons with a chimp or a monkey of some kind. Yeah, this is one theory that has been bandied about. I don't know if things have actually advanced on that score, because you try to look into it and all you find is conspiracy theories these days, unfortunately. So if you've got any hard data, please feel free to leave it in the comments. But as humans expand, as we push into and remove wild areas, we come into contact with new animals or animals with new diseases, things we haven't necessarily been in close contact with before. And then bushmeat and wet markets is a real opportunity for cross-species contamination, a mutation that allows a disease from pigs or pigeons or bats or whatever else to cross into humans through a beneficial mutation. That's why we talk about swine flu or bird flu. It's because this is a disease that affects the animals, not necessarily to a hugely deleterious effect. Perhaps they're just carrying it, but then it crosses into humans, and there it can have a much more profound effect. So that's another big source of diseases, is animals. There's a new problem in that as climate change takes place, as global warming takes hold, permafrost in far northern areas begins to melt away, and a lot of diseases are capable of surviving a very long time, particularly in very cold conditions. Viruses and bacteria that are thousands of years old can spring back to life when the conditions change in such a way as it becomes possible for them to survive. And so as global warming takes hold, as probably inevitably mankind moves north and starts to exploit the resources and so on there, and to set up settlements further and further north in much more close proximity to each other, the cities in the north begin to expand, perhaps. The opportunity for these ancient diseases to reawaken and take hold is really there. We know this is possible because some lunatic Russian scientist took samples, found novel microorganisms from where the permafrost was melting, and injected himself with them. So that very well could have been a zombie outbreak. Fortunately, it wasn't, and he survived, and it had no real effect on him. But it's quite possible that ancient diseases, even ancient human diseases that we no longer really have immunity to, could be released as the permafrost retreats, and as we settle in larger and larger numbers, as we travel in larger and larger numbers to the far north and the far south. So that's something to be concerned about. Man-made diseases is obviously another potential problem. It's been the plot of many a terrorist movie. Certainly we know that biological warfare divisions still have samples of smallpox and other diseases, and as we now have CRISPR technology, it's become a hell of a lot easier to engineer organisms, parasites, bacteria, less so viruses, but to engineer them to have particular effects, to create particular responses. We could engineer something, hypothetically, that is capable of getting around most conceivable protections that our bodies have, because it's not going through a natural arms race of evolution, with the immune system reacting to the pathogen, reacting to the immune system, reacting to the pathogen. It's something entirely new. Now, this can be good in some ways because we can use microorganisms that we've engineered in positive ways, but we do have to keep in mind that it can be used in extremely negative ways. One last source of diseases used to historically be a huge problem, and it's not really anymore because we live in such a globalized world, but encounters between humans from one area and humans from another area, potentially in a science fiction setting. It could be a new race of aliens or whatever, provided your biology is roughly the same. But when people from one area encounter people from another area, they would trade diseases, and generally speaking, one half of the equation would not come off particularly well from that. If you've read Jared Diamond's Guns, Germs and Steel, he has his hypotheses on this, or draws on other people's hypotheses on this. The reason that disease was so devastating in the New World, he posits, is essentially that the Americas are on a north-south axis, and it's much harder to travel, it's much more different to travel from north to south than it is east to west. And if you look at the Eurasian continent, it runs east to west. We were more technologically advanced, we were more cosmopolitan, we travelled more, we experienced other people more, and so we were like a big petri dish. And then when we moved to the New World, we took all the old world diseases with us that were all extremely robust, and there were lots of them, but we had developed immunity to a lot of them. But these new people who had not travelled and intermingled to the same extent were then extremely vulnerable to these diseases. So that's something you can bring in fantasy worlds. In fact, a large amount of prejudice, as we're seeing now with Chinese people being targeted, or any Asian people being targeted. There's a lot of prejudice when a disease originates from somewhere and becomes associated with the people of that area. It can lead to bigotry and other social problems, which we should be concerned by. And so when it comes to space games, if you're going for something more hard science fiction, this is something you need to think about. So how a disease is transmitted, one way is via insects or parasites, mosquitoes, ticks, lice, that sort of thing. As well as being an infection themselves, parasites can carry other diseases with them, and they often lead to immunosuppression and general weakness that makes you more vulnerable to diseases. So those things can quite often be comorbid. Of course, an insect doesn't necessarily have to bite you, you don't have to eat it or whatever else for it to transmit a disease to you. A fly can land on a turd and then land on your food, and then you get the disease from there. So insects and parasites as an intermediary vector of disease, these are quite common. There's aerosol transmission, so a cough or a sneeze, sputum, kissing, licking pots of ice cream in supermarkets. These are ways of transmitting the disease outside the body, because your sputum, or is it sputum? Anyway, the stuff, the saliva, the mucus, the other stuff that you give off is often swarming with the virus or the bacteria. And many of these viruses and bacteria induce that kind of reaction because they've evolved to do so, because it helps the disease to spread. So kind of on from that, there's body fluids, so contact with your blood or your semen or your vaginal secretions or in your poop or in your pee or whatever else, that can transmit diseases. Often because that's part of how the disease operates, because it wants to spread to others. This is why clean water is so fucking important, and why clean food is so fucking important. So food and drink is another way. If your water source is contaminated, it can pass around. A huge outbreak in London in mid-Victorian era was traced to a single water pump. So you have to think about the infrastructure around the disease and how it can be passed on, what the source is. And once they closed that down, it helped control the spread. So that's another example. Close contact. Most diseases can't last for that long outside the body necessarily, unless the conditions are right. So prolonged close contact, skin on skin, particularly for fungal infections, things like that, they can leave spores on surfaces, or they can leave spores on your skin that you can then pass to other people. Infection rates are an important thing to consider. As we've covered, the coronavirus may get around to about 60% of humanity in this bout, unless it turns out to not like the warmer weather or whatever. A severe disease with a high infection rate and a fast onset period is not actually the deadliest disease on a societal level, because it infects so many people so quickly, so easily, overwhelms them and kills them so quickly that they never get the opportunity to pass on to others. COVID, for most people, it's not particularly severe. So they go about their day, they continue to go to work, they continue to go to social gatherings, maybe they've just got a slight sore throat or a touch of the sniffles or whatever it is. And that's actually worse, because then they're able to spread it on to hundreds, potentially thousands of other people. So a high infection rate but a low mortality can be worse than a disease that's far more deadly, because it just cuts out the opportunities for it to pass on. I mean, the fact that the cities were such a hive bed for the Black Death was because people were living cheek by jowl, passing it on to each other. The vector was fleas, places weren't particularly clean, people were living alongside animals. But in the countryside, where people were more spaced out, it didn't travel so quickly. But the sheer amount of people that it killed also helped burn out the infection. And then when it came back, as it did several times, it was less harsh each time, partly because the population was thinned out, partially because people had had it and recovered and had immunity. So these are factors you need to consider if you're making up a fictional disease to pass on to others. The effects of disease can be massively wide-ranging, even without dipping into science fiction or magic. A lot of them, it's the immune response that does us in. We run a fever, we sneeze, we get a sore throat, we get swollen glands, things like this is all our body trying to fight the disease. Some diseases can compromise that immune system response, like AIDS, HIV. That cripples our immune system, and it's not really the HIV that kills you, it's the secondary infections, typically, like pneumonia or whatever else. So a disease can make our response to disease worse, and then something else will nobble you. Diseases can use up resources in your body. Massive bacterial infections or masses of parasites can lead to you weakening, not digesting your food properly, the parasites hijacking the sustaining proteins and fats and sugars and so on from what you eat for themselves. So that can slowly run you into the ground. There can be wild physiological effects, warts, growths. If you look up the papillomavirus in rabbits, this seems to be where the idea of the jackalope has come from, the horned rabbit, because the papillomavirus in rabbits leads to these kind of hoary keratinous growths, which can look like horns. If it blocks the rabbit's mouth or eyes or ears or its anus, it can end up killing it. But you can have diseases that cause massive growths and warts and so on in humans as well. This is a thing that happens. Genital warts, ribbed for her pleasure. There can be psychological effects. Beyond the delirium and so on that comes with fever, some diseases seem to affect our behavior or our hormone levels, things like that. And there are some diseases that affect behavior on a more profound level. There's a disease in rats that causes them to become attracted to the smell of cat urine and to become fearless, almost. That same disease in humans may account for some of our positive reactions to cats. There are diseases that can change our behavior in subtle ways. In animals, it's easier to see, but we see the animals acting in an extremely aberrant way. The biggest example of this is probably the cordyceps fungus, which when it infects certain insects or caterpillars or other creatures, it can lead them into almost zombie-like behavior. So ants with a cordyceps infection will climb to the highest thing that they can find before dying, and then the fungus releases the spores. There's a similar disease, I believe, in caterpillars that causes them to climb to the tops of trees and then dissolves their bodies into a goo that kind of drips down and infects anything else in the area. Imagine those brought up to a human scale, and it's quite creepy, quite creepy indeed, and potentially very disgusting. Lots of bacteria produce harmful effects as a side effect of them replicating in large numbers. As we covered, the botulism toxin comes as a side effect of a bacterial infection from the biology of the bacterium. Some diseases kill off cells, leading to ulceration, gangrene, hemorrhaging, brain damage, all kinds of horrible nastiness. Now, that's just the effects on you as an individual organism. As we're seeing, there's runs on the stock market, there's massive economic and social implications from disease, bigotry. we're seeing all this play out. It's tempting to take a very sort of shallow look at a disease in a game world that we construct, and to imagine that everyone will react rationally, particularly in a science fiction setting, to the outbreak of some disease. But as we're seeing, people just don't. I mean, anti-vaccination is a thing, for fuck's sake. People aren't necessarily rational actors, and this can lead to far-reaching implications, socially, economically, psychologically, all manner of problems. Fear makes people act in irrational and frequently nasty ways, so that's something to consider. So how do we fight disease, potentially? First, you've got to recognize that there's an outbreak. Then you have to understand it, gene map it, things like that, understand how it transmits, at what rate. This is all data gathering, and unfortunately people have to be being infected and dying while that's going on. We can develop vaccinations to prime people's immune systems to fight the disease, whatever it might happen to be. That takes a long time. Even with completely modern methods, it looks like coronavirus isn't going to have this coronavirus, COVID-19, isn't going to have a vaccine for 18 months or so from when it was recognized as being a problem. So, that takes time. There's not a lot you can necessarily do about that. When it comes to bacteria, there's antibiotics, but antibiotics are losing their effectiveness on a lot of bacteria as they're mutating to cope with it, because lots of people don't take their full course of antibiotics, or they ask for antibiotics when they don't need them. And this causes all sorts of problems. Antivirals are relatively new, not particularly great as a drug for treating disease yet. Interestingly, one potential cure for bacterial infections is viruses. There's a type of virus called a bacteriophage, which infests bacterial cells and kills them and turns them into more versions of the virus. And these don't necessarily affect humans, don't affect human cells. There have been successful treatments where rampant bacterial infections have been cured using massive injections of viruses, bacteriophage viruses. This is still in its early days, but in a science fiction world, maybe that's more possible. We can poison parasites because, being so small, they're much more vulnerable to toxins than we are. I mean, your anti-malarials are essentially poison, but poison that doesn't affect you, but will affect the malaria parasite. Though again, evolution is not necessarily our friend there. In the future, we may be able to have things like programmable nanite swarms that can be given an IFF system to recognize hostile infections and remove them, and that will be basically game over for most diseases, except the very, very novel ones. If we can get microbe machines that can hunt and kill diseases and cells that shouldn't be there, like cancer cells and so on, then that's it, game over. Of course, machines that can do that can also be artificial infections. So the fight against disease may well become more like the fight against computer viruses in the future, just to think about that. Of course, in a fantasy setting, or a science fiction setting, or a science fantasy setting, there's lots of out there ideas that you can have for diseases. Perhaps a disease that is a hive mind, and once it reaches a critical mass of people who are infected, it psychically stitches all of those minds together and bursts forth into sentience and wants to spread itself to even more people. The idea of memetics, informational diseases, which some people have characterized religion as, and I would quite frankly agree. But there could be informational diseases that pass from one person to another through information, ideas, toxic ideas. There can also be positive memes. There could be a psychic disease that passes from mind to mind through telepathy. That could be another vector of disease. And as we've covered, there's also nanotech. Diseases are interesting, and finding cures or combating a disease or having to work in the aftermath of a disease or in the middle of an outbreak, These can all add flavour and additional challenge to the kinds of things that we have people do in games all the time. And if there's any silver lining to this, it's increased health awareness and increased awareness in people of just what mass disease really means. Because it's not something that's affected the Western world really for some time. Probably the last time we had anything like this kind of response was the AIDS panic in the 80s. But it's worth thinking about, and you can draw inspiration from real life, and that's where we are now. Zang.
The normal question, the first question is always, are these cannibals? No, they are not cannibals. Cannibalism in the true sense of the word implies an interspecies activity. These creatures cannot be considered human. They prey on humans. They do not prey on each other. That's the difference. They attack and they feed only on warm human flesh. Intelligence? Seemingly little or no reasoning power, but basic skills remain are more remembered behaviors from normal life. There are reports of these creatures using tools, but even these actions are the most primitive. The use of external articles as bludgeons and so forth. I might point out to you that even animals will adopt the basic use of tools in this manner. These creatures are nothing but pure, motorized instinct. We must not be lulled by the concept that these are our family members or our friends. They are not. They will not respond to such emotions. They must be destroyed on sight.